So now let's work exercise 3 on our linear functions handout. At hour t equals 0, there are 3,200 cubic meters of water in a reservoir. Water is being pumped out at a constant rate of 20 cubic meters per hour. We need to set up a function to model this process, and we need to figure out how many hours it will take for the reservoir to reach 2,000 cubic meters. Now, I am using units written in a certain way here, so just notice that m cubed, that's not a variable cubed. That's just shorthand, an abbreviation for the words cubic meters. It's a pretty standard way of abbreviating those units. So we're dealing with units of volume here. And those are going to be our output units for the function. So for part A, we want to set up, I guess I'm using input variable t again here, so I am going to use f of t. Our function, what kind of function is it? Okay. The signal to us here in the statement of the problem is this constant rate of water being pumped out. Because we see that constant rate of change, that's really our signal that we have a linear function. So we can write our function f of t in the form mt plus b. And we need values for m and b. Now, 20 cubic meters per hour is that constant rate of change. We're going to replace m with a number here. And what is that number going to be? It's not actually going to be exactly 20, right? It's going to be a little different from that. It's going to be negative 20. Okay, can you see this negative 20 reflects the fact that our function is going to be, the graph is going to be falling from left to right. The amount of water in the reservoir is going down. So water is being pumped out at a constant rate. If water were being pumped in at a constant rate, we would use positive 20. So there's no real calculation here. You just got to be aware that the slope is negative 20. Okay? And then at hour t equals 0, there are 3,200 cubic meters. That's our y-intercept. So they're actually just telling us our b value, right? So here we're just plugging in numbers that we see to get this formula. F of t equals negative 20t plus 3,200. And it's probably, I just want to say, t is hours. F of t is cubic meters. Cubic meters of water in the reservoir. And now we got to answer question B. How many hours will it take for the reservoir to reach, what is that, 2,000 cubic meters? So it's the level is going down, right, from 3,200 to 2,000. So we want to find t that solves, or for which f of t is going to turn out to be equal to 2,000. So we take our formula, and I'm going to replace the f of t output with this value, 2,000. And we got to solve for t. And this is not too complicated here. I got to subtract 3,200 from both sides, right? I think I'm going to get negative 1,200 equals negative 20t. I hope I did that okay in my head. And then I'm going to divide both sides by negative 20. to get T. And I think here I got 60. So we got T equals 60 hours. And that's for the reservoir to reach 2,000 cubic meters. Okay, so that's exercise 3. Let's go right on to, I think I'm going to stop. I'm just going to leave exercise 3 on one video. We'll do 4 on a separate video.